It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.
Yes. Hello students. Welcome to the session. Welcome to Unacademy Telugu channel. Before starting today concept, student, let me introduce myself. Students, my name is Surendra Babu. For 10 years, I am educating the students for GATE, ESE and PSUs in the field of electrical and electronics engineering. Students, these are the subjects I am teaching for electrical students: power electronics, power systems, electrical missions, electrical and electronic measurements. Then this subject I am teaching for instrumentation students, that is the transducers and mechanical instrumentation. Students, apply my promo code BABU10, apply my promo code BABU10 and get the 10% discount on Unacademy Plus subscription. This is about me. Yes, now come to the our Unacademy subscriptions. There is a plus subscription and there is an iconic subscription. Friends, if you select the plus subscription, these are the benefits you can get: live classes, crash courses, weekly tests, doubt solving sessions, that is available in English and Hindi. Friends, there is one more subscription, iconic subscription. If you select the iconic subscription along with the plus subscription, these extra benefits are added. Then what are the extra benefits, sir? Personal coach is available, study planner, study booster sessions, personalized test analysis, preparatory study material. So all these are the extra benefits are added if you select the iconic subscription, student. Okay, this is the advantage selecting the iconic subscription. Plus subscription, these benefits, no doubt at all. But you want extra benefits, then you go for the iconic subscription also. Sir, how to get our Unacademy app, sir? Then search Unacademy Learning app in Play Store. The second step is install the app, the student. The third step is select your goal, sir. Select your goal. Here our Unacademy is educating so many courses. Then you are in GATE and ESE means, then you select the GATE and ESE. Then select plus, get subscription. This is about how to subscribe our Unacademy Learning app. Students, whatever after downloading this Unacademy Learning app, use my promo code BABU10 to unlock the app. Okay, that you follow. Now come to the course fee details for GATE and ESE for plus subscription students. GATE and ESE for plus subscription for 12 months program. Apply my promo code BABU10, get the 10% discount and you pay only 27,225 rupees. This also plus subscription students for GATE and ESE. Apply my promo code BABU10, get the 10% discount and you pay only 34,650 rupees. Yeah, this is 18 months program, students. It's 18 months program, 1.5 year program. For 1.5 year, you are paying only 34,650 rupees for a plus subscription, students. And this is 2-year program for both GATE and ESE, 2 courses, GATE and ESE. For plus subscription, apply my promo code BABU10, get the 10% discount and you pay only 39,600 rupees, students. This about plus subscription course fee details. Plus subscription course fee details. Yes, sir. See the iconic subscription course fee details for 12 months program students. Apply my promo code Babu10. Get the 10% discount and you pay only 45,225 rupees. Yeah, this is for 24 months program students for iconic subscription. Then 2-year program. Apply my promo code Babu10. Get the 10% discount. Then you pay only 66,600 rupees students. Yeah, these are the course fee details for iconic subscription. Students, you please concentrate. These are our top educators who are teaching in plus batches for Triple and ECE. You please concentrate. Target ESE Prelims 2021. Rank booster batch for GATE 2021. Target ESE Prelims 2021. Rank booster batch for GATE 2021. This electrical batch, and this is electrical, and this is ECE, and this is also electrical students. You please concentrate. These are our top educators who are teaching in plus batches. This is our Unacademy GATE Telugu December month schedule and crash course schedule also. Students, the subjects are given along with the timings is also mentioned. Follow all these timings without missing in order to crack mainly GATE and ESE point of view. These are Unacademy GATE Telugu December month schedule students. There is communication systems, electrical missions, engineering mathematics, power systems, aptitude. And this is crash course subjects, power electronics, EDC and aptitude students. You please concentrate. These are our GATE 2022 batch A electrical. These are our top faculty who are starting at 21st December. You ready for join students? Students, now come to the today concept. That is power system 1 I am teaching. That is chapter 3 I started in the last session. That is fault analysis. Then after introduction I am starting the unsymmetrical fault analysis. In that unsymmetrical fault analysis, today is line to ground fault students. Today I want to discuss the fault analysis. That's fault calculations in line to ground fault. If there is any line to ground fault is occur, LG fault students, then what is the fault analysis we can do? What the fault calculations we can calculate? That I want to discuss in detail. That is very important to solve the GATE questions or ESE questions or BSU's questions, students. Yes, students, all of you, good evening. Yes, good evening. Very important topic. I'm starting LG fault students. It's very important for GATE point of view. And even for ESE point of view, for BSU's point of view also, whatever the observations I will give in the LG fault analysis, that observations you follow, then to solve any questions in GATE and ESE point of students. Students, shall we start? Yes, you please inform to your friends. Then I'm starting the today concept, that is LG fault analysis. Line to ground fault analysis, students. Yes. Here in the single line to ground fault, here first I am assuming that, let us assume that there is no any fault impedance. Without fault impedance, with ZF equal to 0, students, where ZF equal to fault impedance, where ZF equal to fault impedance. With ZF equal to 0, I am explaining this. This is the case 1. But if ZF is also considered, what is the analysis? Later on I will give. First I am starting, there is no any fault impedance. Let us assume that this is the generator. Yes, students, let this A phase voltage is EA and this is B phase voltage is EB and this C phase voltage is EC, students. Okay, this is EA, EB, EC. Let it is grounded through impedance of Zn. This is the neutral is grounded. The neutral is grounded through impedance of Zn, students. The neutral impedance is Zn. The neutral impedance is Zn. That is neutral is grounded through Zn impedance. Okay. Let this is the A phase current and this is the B phase current and this is the C phase current, students. Yes, this is A phase, this is B phase and this is the C phase current. Okay, students, let this is the A phase voltage, terminal voltage, this is the B phase voltage and this is the C phase voltage. the notation. Let assume that there is a line to ground fault. That is from one phase to ground. From any one phase to ground. You take from any one phase to ground. Here I am taking line A to ground. There is a fault takes place. Well, let assume that this is the line to ground fault. There is from line to ground fault I am taking. Let this is from line A to ground. There is if any fault is occur. Let that fault current is IF, students. There is some fault current. Let that fault current is IF. Here I am assuming that there is a from line to ground, student. This is the line to ground fault I am assuming. Let the fault current, because if there is any fault is occur, there is a fault current is flowing. That's why here I am taking the fault current is IF, students. But I am not considering any fault. If there is a current is flowing, for the flow of that current, there must be some impedance is also offered. But that impedance I am not considering in this case. Understood? I am explaining without ZF, students. That you concentrate. Yes, this is the fault current. First, you will see what is the free fault conditions of. What is the free fault conditions? Free fault in the sense before fault, students. Before fault. A free fault is nothing but a before fault. What is the before fault conditions here? Let us assume that this alternator or generator is under no load condition. This is our assumptions before fault condition. Generator or alternator is under no load condition. Students, these are the observations before fault. Before fault. Generator under no load condition. Yes, students. If the generator under no load condition, you tell me, what is IA equal to 0? IB also 0. There is no current, open circuited, no load is connected here, students. Still there is no fault. If there is no fault, no current is here. I am explaining this without any fault, students, without any fault. Okay, then this is the condition before fault. IA equal 0, IB equal 0, IC equal 0. Why all the currents are 0, sir? I am not connecting any load, sir. Completely open circuited, sir. This is a no load generator. IA, IB and IC 0, sir. Then what about the voltages, sir? This VA, the terminal voltage VA, this A phase voltage equal to this terminal voltage equal to A phase voltage. That is EA, sir. And it is also equal to EA1, sir. Because if the system, let us assume that there is no any fault, system is under balanced condition, it consists of only which component? Positive sequence component, sir. That's why I written VA equal to EA equal to EA1 also. Then what is the VB you write, sir? This VA, VB, VC are the terminal voltages. EA, EB, EC are the excitation EMFs of the alternator or generator. What is VB, sir? This is equal to EB, sir. That is also equal to EB1. The system before fault, system is under balanced condition. Then what is VC, sir? The terminal voltage of C is equal to C phase voltage, sir. VC equal to EC, sir. That is also equal to EC1. Because system is under balanced condition, it consists only positive sequence component. Students, you please concentrate. These are the observation before fault under free fault condition. This is under free fault condition. You please concentrate. These are the conditions at a free fault, student. Okay. Now let us assume that if there exists a line to ground fault, a line to ground fault is one of the short circuit fault. This is LG fault, students. This is a LG fault. That is one short circuit fault. LG fault is one short circuit fault. I already told. These are the types of short circuit faults only. Now, if any fault takes place, then there is a current, students. There is a current in A phase. But in which phase there is a current? A phase. That's why now IA is not equal to 0, students. This IA equal to IF. This IA equal to IF. Understood or not? Now, if there is any short circuit fault is occur, then this VA becomes 0, students. Why it is a short circuit? Under fault condition, VA becomes 0. But VB is not 0, VC not 0. But VB equal to VB not 0, VC not 0. But which is 0? VA is 0, students. When any fault takes place, the system becomes unbalanced, no doubt at all. But now what I am telling, if any fault takes place, because it is a short circuit fault, this VA becomes 0. But IA is not equal to 0. IA equal to IF. But what about IB and IC? That remains 0 because there is no current here, because these two are open circuited. Understood, student? Now I am writing this one. You please concentrate. This under fault condition, under fault condition, under fault. Then which fault, students? Here I am telling that under fault condition means which fault? I told that it is a line to ground fault. Is which fault? It is one of the short circuit fault. Under fault condition. That is which fault? This one, short circuit fault. Short circuit fault. This is the LG fault. LG short circuit fault. Okay. Under fault condition, what the observation, students? This IA equal to IF. This IA equal to IF. Is it correct? Whatever the A phase current is there, that is the, I am assuming that the fault is at which phase? A phase. The fault is at which phase, students? I am assuming that this is one. I am assuming that the fault is at A phase. If the fault is at A phase, there is a fault current. That current equal to A phase current. That is IA equal to IF. Then one more observation. What about VA equal to 0, students? VA equal to 0. Sir, why VA equal to 0? It is a short circuit fault, sir. VA equal to 0. But what about remaining IB and IC, sir? IB equal to 0, sir. IC also 0, sir. But VB and VC not equal to 0, sir. Is VB not equal to 0? VC also not equal to 0. That is similar to free fault condition. But here under fault condition, mainly these two are changing. IA equal to IF, VA equal to 0, student. Clear? These are the observations if any LG fault is occur. Very important. By writing this condition, then you write any formula. Please concentrate, students. You are writing by your own. Don't by heart what I am telling. You analyze like that what I am analyzing. You follow like that only. You analyze by your own. The concept you analyze by your own. Then only that type of analysis is important for competitive point of. Okay, students. Then what I am telling that here IA equal to IF, sir. VA equal to 0. Why VA equal to 0, sir? There is a short circuit fault at A phase, sir. If short circuit fault, what the voltage, sir? 0. But which current is flowing, sir? Fault current is flowing. What is that IA equal, sir? IF. But why, sir? IB and IC 0, sir? There is no fault here, sir. There is no fault here. Only fault is takes place here. Yes, sir. Now, with this, first I am writing what the symmetrical components of currents. We know that if the system is subjected to the fault, it becomes unbalanced. Now you want to write symmetrical components. Now symmetrical components of currents. Symmetrical components of currents. Components of currents. I am writing symmetrical components of currents. Then what are the symmetrical components of currents, sir? Here, what is IA naught, sir? Very important observation, students. Here, IA naught equal to 1 by 3 into IA plus IB plus IC, sir. IA plus IB plus IC, sir. What is IB IC, sir? Under fault condition, IB IC 0, sir. But what is IA, sir? IA equal, that is IA by 3, sir. This is IA by 3. But that IA equal to IF, sir. That equal to IF by 3. So, okay, students. Now, what is IA1, sir? What is IA1? IA1 equal to 1 by 3. IA1 1 by 3 plus IA plus alpha IB plus alpha I square. Sir, alpha square IC, sir. These formulas you know, sir. Again, you substitute IB 0, IC 0, sir. Please, students, concentrate. You have IB 0 and IC 0, sir. This becomes 0. Then what you can get? IA by 3. Okay, this is also equal to IF by 3, sir. Understand? Then what is IA2, sir? What is IA2? What is IA2 in symmetrical component? That you know this formula, students. IA plus alpha square IB plus alpha IC, sir. Okay. Now you substitute IB 0, IC 0, sir. Again what you can get, sir? IA by 3. That equal to IF by 3. Yes, students, you concentrate. That means what is the observation? IA not equal to IF by 3. IA1 equal to IF by 3. IA2 equal to IF by 3. That means under LG fault condition, this very important observation, IA not equal to IA1 equal to IA2. All the three symmetrical components of currents are equal. Zero sequence current equal to positive sequence current equal to negative sequence current. Very important. Sometimes the questions are asking By giving this type of condition, what is the fault it is asking? Okay, this is giving the condition like this, then identify the fault. If this condition is satisfied, then it is a which fault, sir? LG fault. Like that you remember. IA not equal to IA1 equal to IA2, sir. Students, you please concentrate. Then one more observation, sir. What is this IA not, IA1, IA2, sir? IA not equal to IA1 equal to this IA2 equal to which one, sir? That is equal to IA by 3, sir. This is also equal to IF by 3, sir. Very important observation, students. All these under symmetrical components of currents making the observation, sir. Yes, sir. One more observation, sir. From this only I am writing, sir. Then what is IF, sir? This IF equal to 3IA naught, or it is also equal to IF equal to 3IA1, sir. Because it is also equal to 3IA1, sir. Or it is also equal to 3IA2, sir. It is also equal to 3IA2. Okay, this fault current you want means 3 times of the zero sequence current, or 3 times of the positive sequence current, or 3 times of the negative sequence current you calculate, sir. You can get the fault currents. Is okay, sir? If you want one more here, we know this, sir. IA equal to IF, sir. This also we can write 3A IA not equal to 3 IA1 equal to 3 IA2. Sir, don't feel these are the different relations I am writing like that. All these relations we are writing from this one only. Yes, sir. From this, what is IF, sir? This 3 IA naught, 3 IA1, 3 IA2, sir. Now from this, what is IA, sir? 3 IA naught, 3 IA1, 3 IA2. Okay, this is observations for symmetrical components of current, sir. This is very, very, very important 5 star. This relation. And this relation also you concentrate, sir. From this, you write any relation. Okay, sir. This is for symmetrical components of current. The system is subjected to the LG fault. Then there is unbalance. Then you are writing the symmetrical components of currents. Now similarly, I want to write symmetrical component of voltages, sir. Apply these conditions to find the symmetrical component of voltages. Students, please concentrate. Same single line to ground fault only, sir, with ZF equal to 0. Symmetrical component of voltages. Symmetrical component of voltages. I am writing for voltages, sir. Component of voltage. Now tell me, sir, what is the symmetrical component of voltages here, sir? Symmetrical component of voltages here. Yes, sir. The symmetrical component of voltages is, what is VA naught, sir? First you write what is VA naught, VA1, VA2, sir. This VA naught equal to 1 by 3 into VA plus VB plus VC, sir. But we know this one. What is VA, sir? For faulted, VA becomes 0, sir. At fault condition, what is VA, sir? 0. That's why 1 by 3 VB plus VC, sir. What is VA1, sir? 1 by 3 into VA plus alpha VB plus alpha square VC, sir. But what is VA, sir? This VA is 0 because fault is at A phase, I assume. Then 1 by 3 into alpha VB plus alpha square VC, sir. Sir, what is VA2, sir? Under LG fault condition, all these observations I am writing. Okay, 1 by 3 into, this is VA plus alpha square VB plus alpha VC, sir. Sir, what is VA, sir? This VA equal to 0, sir, because fault is at A phase, sir. Then alpha square VB plus alpha VC. Yeah, this is VA naught, VA1, VA2. Sir, you know that what is VA, sir? VA equal to VA naught plus VA1 plus VA2. This formula you know. But what is VA naught plus VA1 plus VA2, sir? Fault is at A phase. If fault is at A phase, what is VA, sir? 0. A short circuit fault is occur at A phase. That's why VA equal to 0, sir. That's why VA1 plus VA2 equal to 0. This is also very important observation, sir. If the fault is at A phase, because of that, if you want, you substitute all these here, sir, then also you can prove that it is equal to 0, sir. Okay, because already you know VA 0, that's why directly I written, sir. Or otherwise you substitute this VA naught value, VA1 value, VA2 value here, sir, then prove that that is equal to 0, sir. then also you can get 0. But already VA 0, that's why directly I am writing. Why VA 0, sir? Because fault is at A phase. Short circuit fault is at A phase. Okay, that is very important condition. Maximum these two conditions mainly it is giving for LG fault. IA0, IA1, IA2 all are equal. That condition. VA0 plus VA1 plus VA2 equal to 0. This condition. Based on these two conditions, questions are framing. You ready to answer? So, okay, students. Yeah, this is for symmetrical component of voltages. This is the under LG fault condition. What the symmetrical component of currents? What the symmetrical component of voltages? You please concentrate. Clear? Next. Students, please concentrate. Now I am writing sequence networks, sir. Sequence networks. Under fault condition, you already know, sir. Sequence networks. First I am writing under free fault condition. For free fault condition. Free fault in the sense before fault, students. Before fault. We know that under free fault condition, it is having the three networks. One is positive sequence network, another one is negative sequence networks, third one is zero sequence network. This is under free fault condition. If you draw the networks, these are the network, students. Here first I am drawing positive sequence network. Here this is the positive sequence network. Yes, students, our reference is neutral. This plus minus EA1, sir. What is this one, sir? Z1. Z1 or X1, sir. Whatever you take. Let this current is IA1, sir. Now what is this voltage, students? This is VA1. Okay. This is the sequence networks under free fault condition. Here I am drawing the negative sequence network also. Here I am drawing the negative sequence network. Negative sequence network means remove the source, sir. In positive sequence network, remove the source. Then what is this currents are? IA2, sir. What is this one? Z2. Then what is this voltage, sir? VA2. Yeah, this is positive sequence. This is positive sequence network, sir. And this is which one, sir? Negative sequence network. Negative sequence network. Here you take the, our reference is neutral, sir. This is negative sequence network. These are the observations under free fault conditions. Negative sequence network. These networks already you know, sir. Then you draw the zero sequence network, sir. If you draw the zero sequence network, yes, here itself I am drawing the students. Yes. This zero sequence network, ground is also included. Ground is also included, sir. This zero sequence network, this ground is also included. Let it is grounded through impedance, already given this one. Yes, the alternator is grounded through some impedance ZN. Through ZN. Sir, what is this one, sir? This is 3ZN, sir. Why? How it is 3ZN? I already given in the sequence network, sir. This is Z0. Then what is this current, sir? IA0. Then what is this voltage, sir? VA0. This voltage is VA0. Yes. Then what is the Z0 equivalent here, sir? The Z0 equivalent equal to Z0 plus 3ZN, sir. Z0 plus 3ZN. If it is impedance, you take like this. If it is a reactance, sir, X0 plus 3XN, only reactance is given X0 plus 3XN. If impedance is given Z0 plus 3ZN, you can. This is the which networks are? Zero sequence networks. This is the zero sequence network. Students, you please concentrate. These are the observation under which condition? Free fault condition. Before fault, sir. But under fault condition, I am drawing the sequence networks. Under fault condition, we know this IA0 equal to IA1 equal to IA2, sir. All the three sequence currents are equal, sir. If all the three sequence currents are equal, in which connection currents are equal, sir? Series connection or parallel connection? Series. That's why, because of all the sequence currents are equal, then all three networks are connected in series. All three networks are connected in series. Sir, please concentrate. Connected in series. Why I am connecting in series, sir? Because all the three symmetrical component of currents are equal. That currents are equal means under series connection only. That's why I'm connecting like this. This is the sequence network under fault condition. This is the sequence network under LG fault condition. For LG fault, how the three sequence networks are connected? Very important. These three sequence networks are connected in series. Sir, why it is connected in series, sir? All the three symmetrical components of currents are equal, sir. Yes. First I am connecting positive sequence network, sir. This is the positive sequence network. Students, you please concentrate. Yes, this is the positive sequence network, sir. Next I am connecting, yes, clearly I am drawing this. Please concentrate. First I am connecting the positive sequence network. This is the source. Yes, sir. This neutral is the reference. This is plus minus EA1, sir. Next I am connecting the negative sequence network, sir. This is negative sequence network. These all are connected in series. Here neutral is the reference. Next I am connecting the zero sequence networks. In zero sequence network there is impedance also, sir. Yes. This is in zero sequence network, ground is the reference. Yes. All these are joined, sir. Why this is in series, sir? It is given that series, sir. This is Z0, sir. This is which one? 3Zn, sir. Z0 and 3Zn. Okay. These all are joined. This is series, sir. Now what is this current, sir? This is Z2. This current is IA2. What is this current, sir? IA1, sir. IA1. What is this current? IA0. Because zero sequence currents. Zero sequence current. This is 3Zn. This is IA0. This is IA2. This all are equal, sir. Because of which connection, sir? Series connection. Because of this only I connected in series. This is Z2, sir. You please concentrate, students. This is Z2. Giving as a Z2. Okay, this is IA2, sir. This is IA0. Okay, all these are connected in series. Then I am joining like this. Why it is connected in series? Because of sequence, all the sequence currents are equal. All the sequence currents are equal. Okay, this is a connection. Now what is this voltage, sir? This voltage is A1. What is this voltage, sir? This voltage is A2. Students concentrate. What is this voltage, sir? This voltage is V0. This V. Okay. This is voltage, terminal voltage of zero sequence network, terminal voltage of negative sequence network, terminal voltage. Then what is the sum of all these, sir? VA0 plus VA1 plus VA2, sir. All equal to 0, sir. Why it is a short circuit? Okay. VA0 plus VA1 plus VA2 equal to 0. Okay. This is about sequence network. In the case of LG fault under fault condition, all the three sequence networks are connected in series because all the fault currents are equal. The fault currents are equal. Okay, students, you please concentrate. Okay. Yeah, this is an observation under fault condition. Now we can also connect these networks like this, sir. To also connect like this. Here I am giving one more page. Here I am assuming like this, sir. This is also connection. Let this is the positive sequence and this is the negative sequence. That internally consists of its equivalent. And this is the zero sequence network. This network internally consists whatever the equivalent circuit I give. Then this is positive sequence. This is negative sequence component of network. This is a zero sequence component of network. All these are connected in series. This is connected in. Okay, students. Yeah, this is positive sequence network. See, in some exams it is like this also it is giving. That's why I'm connected like this. Positive, negative and zeros. What is this currents are? IA1. What is this currents are? IA2. What these currents are? IA0. This voltage is VA1 sir. This voltage is VA2 sir. This voltage is, yes, you please represent here. This is IA0 sir. This is IA0. This current is IA0. And this voltage is VA0 sir. Voltage is, okay. Like this also we can connect. This also, this is positive sequence, negative sequence, zero sequence. All these networks are connected series. All these networks are connected. Positive sequence, negative sequence and zero sequence. Okay. Now, network analysis. Now I want to explain the network analysis under fault condition. Okay, the analysis of network under fault condition. Work under fault. Now we concentrate under fault condition. What is the analysis of network under fault? From this we can get one formula that is important. What is the analysis, sir? VA0 plus VA1 plus VA2 equal to 0, sir. VA0 plus VA1 plus VA2. This VA0, VA1 plus VA2 equals. What is VA0, sir? Minus IA0 into Z0 equivalent, sir. What is VA1, sir? EA1 minus IA1 into Z1, sir. What is VA2, sir? Minus IA2 into Z2, sir. That equals 0. Students, is it okay? This I am writing this, sir. VA1 equal to EA1 minus IA1 into Z1. This is Z1, students. This is Z2. This is Z0 3Zn. Where Z0 plus 3Zn is equal to Z0 equivalent. Equal to Z0 equivalent. We know this VA0 plus VA1 plus VA2 equal 0. In this I am substituting this voltages, sir. What is VA1, sir? EA1 minus IA1 into Z1. What is VA2, sir? Minus IA2 into Z. What is VA0, sir? Minus IA0 into Z0 equivalents. Z0 equivalent. That I written here. Okay. Now from this, sir, what is EA1, sir? EA1 equal to, that is IA0 into Z0 equivalent plus IA1 into Z1 plus IA2 into Z2, sir. Plus IA2 into Z2. Students, concentrate. Here we are getting one important formula, IA2 into Z2. But you know this, IA0 equal to IA2 equal to IA1, sir. I am replacing all these by IA1, sir. Then what is EA1 equal to? This is IA0 into IA1 into Z0 equivalent, IA1 into Z1 plus IA1 into Z2. Because all are equal, sir. That's why I am replacing with IA. Then what is IA1, sir, from this one? IA1 equal to, that is the positive sequence of current, symmetrical component of current equal to EA1 by S, sir. Z1 plus Z2 plus Z0 equivalent. Very important. Therefore, EA1 by, what is this one, sir? Z1 plus Z2 plus, what is the Z0 equivalent, sir? Z0 plus 3Zn. This is the calculation of symmetrical component of current. Symmetrical component of current using which fault? LG fault, sir. This is IA1 equal to EA1 by Z1 plus Z2 plus Z0 equivalent, sir. That is IA1 equal to EA1 by Z1 plus Z2 plus Z0 plus 3Zn, sir. Z0 plus 3. Students, you please concentrate. Okay, this is the symmetrical component of current. Once you know the symmetrical component of current, now I want to calculate fault currents. So, okay, now I want to calculate fault currents. Students, concentrate. See, what is IA1 I got? IA1 equal to EA1 by, sir, Z1 plus Z2 plus Z0 equivalent, sir. Or you also write if it is given only reactance, sir. IA1 equal to EA1 by That is Z1 plus Z2 plus X naught. Sorry, I am asking about only reactance is given. Then you write, sir, X1 plus X2 plus X naught equivalent. This is also correct, sir. Only reactances are given. If impedances are given, take this one, sir. What is the X naught equivalents are here? X naught plus 3xn. If only reactances are given, you take like. Okay. Now once you know the IA1, sir, what is the formula for IF or that equal to IA, sir? What is the formula? 3 into IA1, sir. This formula you know. Then 3 times of what is IA1, sir? EA1 by then Z1 plus Z2 plus Z0 plus 3Zn equal to 3 into EA1 by, sir, please concentrate students, Z1 plus Z2 plus, what are the 3 Zn, sir? Z0 equal, that is Z0 plus 3 Zn equal to Z0 equal. This is the calculation of fault current. How to calculate the fault current? This formula you concentrate. The fault current equal to 3EA1 by Z1 plus Z2 plus Z0 equal. Okay students, you please concentrate. Like this, what are the symmetrical components of currents I given? What is the symmetrical component of voltages also I given? How to draw the sequence networks I explained. From that sequence networks, what is the analysis we can do? From that, how to calculate the fault current, all these I explained. Then how to calculate ABC currents and ABC voltage, phase voltage and phase currents also. See, phase currents, ABC currents, that is the phase currents, sir. You calculate phase currents in this analysis. If you calculate the phase currents in this analysis, sir, then what is phase current, sir? You please concentrate. IA equal to IA equal to IA naught plus IA1 plus IA2, sir. All are equal, sir. IA naught plus IA1 plus IA2. But you know this one, these all are equal, sir. 3 into IA naught. Because IA naught equal to IA1 equal to IA2. All these are replaced by IA naught, sir. But what about IBs are 0? What about ICs are 0? Phase currents also we got. Sir, I want to calculate phase voltages, sir. In the same analysis, all these I am calculating, sir. I want phase voltages, sir. How to get the phase voltage, sir? VA equal to VA naught plus VA1 plus VA2. But this phase voltage is 0, sir. Already you know, sir. What about VB, sir? VB equal to VA naught plus alpha square into VA1 plus alpha into VA2. This formulas you know, sir. What is VC, sir? VA naught plus, yes, please concentrate. VA naught plus alpha into VA1 plus alpha square into VA. Okay, sir. Like this, we calculate phase voltages also. Is correct. Once you know the phase voltage, you calculate line to line voltage also. VAB, VBC, VCA. All these are calculations. These are the fault calculations. These are the calculations under fault conditions, sir. Understood, students? This about what exactly LG fault without that is ZF equal to 0. By considering the fault impedance is 0, these observations mainly concentrate. Clear? This is a very important formula, students. What is the fault current? A fault current equal to, because fault is at which phase? A phase. At A phase current equal 3 times of its positive sequence component current. That's why heavy currents are going, because it is which fault, students? Short circuit fault. It's a short circuit fault. Heavy currents are flowing. Students, understood? You please concentrate. Very important. All the relations and these observations is important to solve the problems. Okay. Now see the students. Now here I want to give one note point. That formula is also important to solve the problems. Yes, sir. Here, friends, please concentrate. In the face, here I want to give one note. For example, in the above analysis, if IF is calculated in per unit, If IF is calculated in per unit, sir, calculated in per unit, please concentrate. If IF is calculated in per unit, then what the actual fault current you can get, sir? How to get the actual fault current? Then actual fault current equal to this actual fault current IFA equal to IF into per unit fault current into, if IF is calculated in per unit, that is IF per unit, sir, then into base current. How to get the actual value, sir? Base value into per unit value, that gives the actual. Here I am telling that if IF is calculated in per unit, if it is asked what is the actual fault current, then you multiply that fault current into base current, sir. That gives the actual fault current. That gives the actual fault current. Students, you please concentrate. This important point I am giving. Okay. Yes. Generally, this fault current is interrupted by the at breaking by the circuit breakers. How to break this fault current, sir? If there is any fault is takes place, if you want to break that pin, sir, then you allow the relay operation, then open the circuit breaker. That means this fault current is interrupted at breaking. This fault current is interrupted by which ones are circuit breaker, interrupted by circuit. That means a circuit breaker breaks the fault current, sir, breaks the fault current, breaks, hence fault current, hence it is called breaking current. It is called breaking current. That with respect to circuit breaker, that current is called breaking current, sir. That's why the breaking current is nothing but a which current, sir? That is the fault current. The fault current is break by the, that is if there is any fault, if there is any, for example, this is the line, sir. Here I am providing one circuit breaker, sir. If there is any fault is takes place here, sir, any fault is takes place, now the circuit breaker can open the line, and that means it breaks the fault current, and its healthy section and faulty section is separated. And healthy section and faulty section is separated, sir. That means it breaking the fault current. That's why that fault current is nothing but breaking current. Generally, breaking current is nothing but a fault current. What is the breaking current of circuit breaker, sir? It is a fault current only. The breaking current of circuit breaker is the fault current only. Breaks the fault. Understood? Now, what here I want to define what the breaking capacity. I want to define breaking capacity of circuit breaker. This I want to define what is the breaking capacity. Breaking capacity, or it is also called fault MVA, sir. Fault MVA, or it is also called short circuit MVA, sir. Short circuit MVA. This how much current is breaking, that you know. But what is this breaking capacity? In terms of MVA, we want to tell. That is fault MVA or short circuit MVA. Then what is the short circuit MVA, sir? Very important formula to solve the problem, sir. The short circuit MVA equal to 3 into, because it's a 3 phase, we are giving 3 into, that is base voltage into base current, sir. Base voltage into base current. But sir, this base voltage into, but this is not breaking current, sir. It's not base current, sir. It is breaking which current, sir? Actual fault current. Actual fault current, sir. IFA. But I want to write this 3 VB into, in terms of per unit current, sir. In terms of per unit current means, sir, IFU into IB, sir. This is IFU into IB, sir. Okay, shall you write like this? 3 into VB into IB, sir. That is IFU, per unit current. Per unit current. But this is 3 into VB IB is the base, MVA base, sir. Therefore, short circuit MVA equal to base MVA, sir. MVA base. Base MVA into, what is IFU, sir? That you already calculated. 3 into EA1. 3 into EA1 by Z1 plus Z2 plus Z0 equivalent, sir. Z0 equivalent. This is equal to, this is a MVA base, sir, MVA base. Like this, we can, by using this formula, we can calculate short circuit MVA. Base MVA into fault current, sir. Base MVA into, that is MVA base into fault current. MVA base into fault current. Per unit fault current, sir. Use the which ones are short circuit MVA. MVA base into per unit fault current gives the short circuit MVA. Clear, sir? Yeah, that you calculate. That is but if you given in terms of per unit, sir, if given in terms of all these calculations you done in per unit, assume that if EA1 is not given, EA1 is the rated voltage. If that is not given, take 1 per unit, sir. If EA1 is 1 per unit, if it is not given, take 1 per unit, sir. Because in per unit system, you can easily, assumptions you can made easily. Assume that 1 per unit, sir. Then what is the short circuit MVA, sir? During solving a problem, this observation is important. 3 into MVA base. Short circuit MVA is 3 into MVA base by Z1 plus Z2 plus Z0. If it is given reactance, sir, X1 plus X2 plus X0 equivalent, like that you write. Here I am writing in terms of impedances, sir. If it is given in terms of reactance, you replace that one. X1 plus X2 plus X0 equivalent you write. Understood, sir? That is short circuit MVA. Very important notes are all these. You please concentrate. That means what I am giving here. Next, I am adding. That is one more page I am adding. This I am giving as a note point, sir. This also note. That means finally the short circuit MVA, one formula for short circuit MVA equal to which one, sir? MVA base. MVA base MVA into per unit fault current, sir. Per unit fault current is one formula. This is also equal to MVA base into what the per unit fault currents are 3 into EA1 by Z1 plus Z2 plus Z0 equivalent. Or it is also equal to MVA base, sir. MVA base 3 into EA1 by, you also write X1 plus X2 plus X0 equivalent. It's also correct, sir, if reactances are given. Okay. In per unit, if EA1 is not given, then take EA1 equal to 1 per unit. EA1 equal. Students, you please concentrate. EA1 equal to 1 per unit. Okay, sir. This is about what exactly a short circuit MVA can. Short circuit. Clear? Yes, sir. This is about what exactly LG fault without any fault impedance. These observations very important. These observations you can't. Okay. Next, I want to explain what is LG fault with fault impedance, with ZF. Now we calculate with ZF. If the fault impedance is considered, now let us assume that this is IA, you know, all these conditions already you know, this is IA and this current is IB, sir, and this current is IC. Let this voltage is VA, this voltage is VB, and this voltage is VC, sir, and this current is the neutral impedance. This is grounded through neutral impedance, that is Zn is the neutral impedance. This plus minus EA1, sir. Okay, this is minus plus EB1, sir. This is minus plus EC1, sir. Three phase voltages, sir. And this neutral is grounded through Zn. Let there is a fault is takes place. Let the fault is takes place at A phase. At A phase the fault is takes place, sir. Then we are not neglecting any fault impedance, sir. We are assuming that there is a fault impedance. Assuming that there is a fault impedance. This ZF is the fault impedance. Okay. Let there is a fault is takes place, sir. This ZF. Now this current is IF. Current is I. Now with ZF, That means if we consider the fault impedance also, what are the free fault conditions are? This already you know. What are the free fault conditions are? A free fault, as it is you write. The free fault condition is which ones are before fault? Assume that that alternator or generator is the no load condition. IA equal to 0, IB equal to 0, IC also 0, sir. The alternator is assume that under no load condition. What about VA, sir? VA equal to EA, sir. VB equal to EB. And VC also equal to EC. Because under no load condition, this terminal voltage equal to corresponding phase voltages, sir. But system is under balance condition. It consists only which component? Positive sequence component. Okay, these are the observations before fault, sir. Under free fault condition. Clear, students? It is under free fault condition. But under fault, sir, what happened? Under fault condition. Students, you please concentrate. Under fault condition, what is ISR is not equal to 0, sir. It's equal to IF. Yes. What is VA, sir? Yes. This is important here. See, if ZF is not there, you take an VA equal to 0, sir. If there is no any fault impedance. But now here VA is not 0, sir. There is a fault current, there is impedance, there is a drop, sir. IF into ZF drop. Now this is important here. That is IF into ZF drop. VA equal to IF. Then VB is not equal to 0. That already you know. This VC also not equal to 0. That is the observation, sir. That means now VA is not IF is not 0. This VA equal to IF into ZF. That point you can't find. Clear, students? Then with these observations, what are the symmetrical components of currents? First I am writing symmetrical components of currents. Symmetrical components of currents. What are the symmetrical components of currents? Students, please concentrate. Yes, sir. The symmetrical components of currents are, what is IA naught, sir? This IA naught equal to 1 by 3 IA plus IB plus IC, sir. Already IB plus IC equal to 0, sir. Then what is 1 by 3 IF? Similarly, what is IA1, sir? Same calculation, sir. 1 by 3 IA plus alpha IB plus alpha square IC, sir. This IB and IC 0, sir. This is also equal to, this is 1. You please concentrate, sir. This is IA by 3 actually. Is equal to IF by 3. This is IA by 3. Because IB 0, IC 0, sir. This is equal to IF by 3. This is also IA by 3. That equal to IF by 3. Then similarly, what is IA2, sir? IA2 also same. 1 by 3 into IA plus alpha square IB plus alpha IC, sir. This is equal to IA by 3, sir. That is equal to IF by 3, sir. That means all the three currents are equal. That means with ZF also only changing is VA is changing, sir. VA is not 0, sir. This is IF into ZF, sir. Yes, students, please concentrate. Yes, sir. Yes. Here, what is that means symmetrical false currents. IA not equal to IA1 equal to IA2, sir. All the three symmetrical components of currents are equal, sir. This is also you write like this. That means under LG fault condition with ZF or with ZF, this condition is satisfying. This IA not equal to IA1 equal to IA2 equal to, this is IA by 3, sir. This is also equal to IF by 3. That means what is IF, sir? IF equal to 3 times of IA naught. That is also equal to 3 times of IA1. Is also equal to 3 times of IA. Yes, sir. This is 3 IA naught, IA1. This is equal to. But you know this one. What is VA, sir? We know this one. VA equal to IF into ZF sir. But what is IF sir? 3 IA naught. That's why I'm writing 3 into IA naught into ZF sir. 3 into IA naught into ZF. But shall you write like this sir? This is 3 ZF. 3 ZF into IA naught. 3 ZF into. That is fault impedance is replaced by. This fault impedance is replaced by 3 ZF sir. Sequence network, it is replaced by 3 ZFs. That is VA equal to 3 ZF into IA naught. Sir, understood? This I am replacing this IF by 3 IA naught. 3 ZF into IF. Okay, students, you please concentrate. Now see, this about symmetrical components of current, sir. What are the symmetrical components of voltages, sir? Symmetrical component of voltages. Symmetrical component of voltage. Component of voltage. Yes, sir. If you take the symmetrical component of voltages, what is VA, sir? VA equal to VA naught plus VA1 plus, this is VA1 plus VA2, sir. It is not 0, sir. It is equal to 3 ZF into I naught. 3 ZF into IA naught. Okay. 3 ZF into IA naught. It is not 0, sir. It is not 0. This mainly remaining as it is, sir. Whatever the LG fault I given, what is VA, that is VA equal to VA naught plus VA1 plus VA2. This is equal to 3 ZF into I. Then if you want to write what is VA naught, what is VA1, what is VA2, that you write. Then but here VA is not 0, sir. That point you remember. Here VA equal to not 0. But remaining if you want to write what is VA naught formula, that you know. 1 by 3 VA plus VB plus VC. But VA not 0, sir, here. What is VA1, sir? 1 by 3 VA plus alpha VB plus alpha square VC. Then what is VA2, sir? All these formulas you know, but don't substitute VA0 here. That observation is important because of fault impedance. Yeah, this about symmetrical component of voltages. Now I want to give what is the sequence network, sir? Sequence network. Network under fault. Directly I am drawing under fault condition. What is the sequence network under fault condition? The students please concentrate. To take the what the sequence network under fault condition, yes, here also currents are equal, sir. You see, all the currents are equal with ZF also. But what is the observation here? There is a positive sequence network. All the networks we connect in series, sir. There is negative sequence network, negative sequence network, and there is zero sequence network. Zero sequence network. Yes, students please consider. All these networks you can connect in series. You connect in series. Yeah, this also you connect in series. Here our reference is neutral. Here also our reference is neutral. But here ground, sir. This is Z0. This is 3ZN. This is Z2, sir. This is Z1. Then all these you connect in series, sir. But it is connected through some impedance, sir, because there is a fault impedance. This is ZF. This is ZF. Now see, sir. This what is this current, sir? This current is IA1. And this current is IA2, because all the fault currents are equal. This current is IA2, sir. This current is taken as a IA2. But these currents are IA now. This voltage is, what is this voltage? This voltage is VA1. This voltage is VA2. And this voltage is VA0. This is VA. VA1, VA2, VA0. All these three sequence net, positive sequence, negative sequence, zero sequence. But what is the fault current? This one, sir. 3 IA0. Fault current is 3 IA0. But see this one. One important, sir. Here these three currents are equal because series connection. three currents are equal. IA naught equal to IA1 equal to IA2, sir. It is equal to IA2. It is equal to IA naught, sir. If you assume that here IA naught, up to this is IA naught, then how it becomes 3 IA naught, sir? It is KCL is not, sir. In series, current remains same. Here IA naught, this is. But what is the current through fault impedance? It is a 3 IA naught. A fault current IF equal to 3 IA naught, sir. But here it is not satisfying. That's why don't represent like this. That's why I'm modifying these ones. Now what I am doing means, to make this current is constant, I am replacing this like this. Instead of ZF, I am doing which one? 3 ZF, sir. Take the 3 ZF. This is 3 ZF, sir. Now don't take 3 IA naught, sir, here. Now you take IA naught. This is IA naught. Now it is correct. Okay. If you take 3 IA naught directly, then it is not satisfying, sir. Because the series connection, current remains same. You don't get two different currents in one series connection. That's why I'm replacing with this is 3 ZF, sir. This is 3 ZF, this IA naught. Then also you can get same drop. 3 ZF into IA naught or 3 IA naught into ZF is same. Understood, sir? Yeah, this is the sequence network with ZF, sir. This is a sequence. If you analyze the networks, network analysis, if you analyze the fault network analysis, if you analyze this network, sir, you tell me. What about this, sir? VA0 plus VA1 plus VA2, sir. VA0 plus VA1 plus VA2 is not zero, sir. It is not completely short circuit. It is short circuited through some impedance, sir. That's why there is a drop. 3 ZF I0. 3 ZF I0. See the difference, previous one and this one, sir. In previous case, this is completely shorted. That's why we've taken 0 here. But it's not 0, sir. There is a drop. 3 ZF into IA0. Then what is IA0, sir? Minus IA0 into Z0 equivalent. What is VA1, sir? EA1 minus IA1 into Z1. What is VA2, sir? Minus IA2 into Z2 is equal to 3 ZF I0. 3 ZF IA0. This is 3 ZF IA0. Please correct that. Is equal to 3 ZF IA. Sir, we know this IA0 equal to IA1 equal to IA2, sir. Now all these I am replacing with IA1, sir. Shall you write like this, sir? Then EA1 equal to you bring this one this side, sir. Replacing by IA1. Then take IA1 is common, sir. IA1 is common. What do you write, sir? Z1 plus Z2 plus Z0 equivalent plus 3 ZF, sir. 3 ZF. And from this, what is IA1? This IA1 equal to EA1 by Z1 plus Z2 plus Z0 equivalent plus 3 ZF. See that, sir? Previous one and this one is only difference is where we are not getting ZF, but here we are getting 3 ZF, sir. That is the only difference. That is a ground fault with fault impedance. This extra term is added in the calculation of IA. The calculation of IA1, this extra term is added. Yes, sir. Once you know this symmetrical component of current, then how to calculate fault current, sir? The fault current IF equal to, or this is equal to IA, sir. How much, sir? 3 IA1. And this is equal to 3 into EA1 by Z1 plus Z2 plus Z0 equivalent plus 3 ZF. This is the calculation of fault current if fault takes place along with the extra term we are getting this one. What is Z0 equivalent, sir, here? Z0 equivalent equal to Z0 plus 3 Zn, sir. This, you know this one, Z0 plus 3 Zn. This Z0 equivalent, sir. This Z0 equivalent is equal to Z0 plus 3 Zn. Students, you please come. Z0 plus 3 Zn. Yeah, this is the with sometimes only reactance is given, sir. Then what is IF equal to? IA equal to 3 IA1, sir. Is also equal to, that is 3 into EA1 by 3 into EA1 by what you write, sir? This is x1 plus x2 plus x0 equivalent If only reactance is given plus this 3ZF, or you can write 3XF, sir. 3XF, or you can write 3ZF. Only reactance is or fault impedance is given. Yes, only reactances are given, like this also you can. Okay, this IF equal to IA equal to 3IA1, 3 into EA1 by x1 plus x2 plus x0 equivalent plus 3ZF. Clear, students? Yeah, this is about what exactly? Sir, one observation, sir. If you take with fault impedance, this is the fault current we are getting. Without fault impedance, this term is not there. That means in denominator, this term is increasing, sir. Whenever this term is added, this term is, denominator term is increasing, sir. Then what about this term? Reduces. That's why fault to current with ZF, fault to current with ZF is less than fault to current without ZF. Without, that means without any fault impedance, we can get the more fault current. If there is a fault impedance, we can get the less fault current. That means here, because of this ZF, fault current is limited. This fault current is reduced. Understood? Why, sir? In denominator, 3 ZF term is added. That denominator term is increasing. That value will reduce us. Understood, sir? Okay, these observations you remember. Whatever the same. Very important condition here, sir. IA not equal to IA1 equal to IA2. These things very. VA not plus VA1 plus VA2 equal 0 without ZF. With ZF, VA not plus VA1 plus VA2 equal 3 times of ZF. 3 times of ZF into IA naught. Understood? That you calculate. Next, to concentrate on how to calculate short circuit MVA. Short circuit MVA or fault MVA or breaking capacity. How to calculate? In per unit calculation, if particular rated voltages are not given, sir, you take 1 per unit, sir. All these observations important during solving of the problem. Clear, students? Is it okay? This about in detail what exactly single line to ground fault. Single line to ground fault with ZF and with. The next coming session, I will explain single line to ground fault with isolated neutral. That one concept. Then along with, I will explain the line to line fault. Line to line fault. These two I will discuss in the next sessions. You please ready to concentrate all those concepts. Very important concept who are preparing for GATE, who are preparing for ESE, sir. Okay, this derivation is mainly important for ESE point. Final formulas is important for GATE. At the same time, in between the concept what I explained, that concept also important for GATE point. Understood, students? You please concentrate. Yes, students, this is our Unacademy Combat, India's largest competition for GATE. You please concentrate. Challenging questions by best Unacademy educators, super fast and fun with real-time rankings. You please concentrate. Detailed video solution by this also complete with the best. Know where you stand among us all other contests. Yes, detailed video solution by top educator students. You please concentrate. Then compete with best and win amazing prizes. Amazing prizes, students. Then register now, students. Only today only. Enroll free. Pre-enroll. Then tomorrow is the contest. Please participate for Unacademy Combat. Win exciting prizes. Know where you are as compared to with others. There is a first and second, third prizes are there. Top 100 rankers also you can get the prizes. This is India's largest fortnightly competition for GATE. Challenging GATE questions created by best educators. Super fast and fun with real-time rankings. Compete with best. Detailed video solutions by top educator after completing the competition. For every question, there is a detailed video solutions. Okay, this is our Unacademy Combat. Please ready to register today. Our competition will start tomorrow, December 16th, 6 p.m. students. December 16th, 6 p.m. You ready to? Yes, students, please concentrate. Students, follow me on Unacademy using this Unacademy user link. Download Unacademy app follow me special classes, different concepts I am explaining the special classes also. You please follow. This is our Unacademy GATE Telugu Telegram channel. You register this Telegram channel, whatever the concepts we are explaining, all these I explain different concept. That uploading as a PDF material, that is more useful for your reference purpose. This is India's #1 study channels. Pediatrics GATE, Electrical, EC and Instrumentation, Unacademy GATE Mechanical, Unacademy GATE Civil Engineering, Unacademy GATE Telugu, Unacademy SSC JE, Unacademy Computer Science, Unacademy GATE Questions, Electrical Junction, Engineering Patashala, GS Territory. Students, so many India's #1 study channels. You please subscribe all these channels for more updates. Okay, thank you. Students, we'll meet tomorrow session.
It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging GATE contest engineered to give you an experience like none other.
where you put your knowledge to test.
and battle it out with the best.
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for GATE till date, with the best of the questions by best educators.
With detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack GATE deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate GATE challenge. Unacademy Combat. Register now.